Well, welcome. You're watching CXC videos, Education for Advancement. I'm your tutor, Mr. Lennon. Well, this is a Saturday, 15 November 2014 review of the JSS 5th Form After School Math class. The content reviewed today, you can find it in your textbook, Mathematics, a Complete Course with CXC Questions, Volume 1. And these were the topics covered: laws of indices. The pages can be found in your textbook along with the examples, 51 to 53. Binary operations, again, pages and examples. Simplifying algebraic expression, pages, examples, and solving linear equations. The pages and examples can be found there. Hopefully you can see this. Next, video tutorial part 1 of 4. So we have these 4 topics that was covered today in after class. That will be covered in a four-part video tutorial. Now, pages 276, example 50. We'll be looking at laws of indices in this first video. Express each of the following products in index form. Now, what are powers? Well, powers are repeated multiplication of the same quantity, referred to as the base, the quantity. And the powers have several names. All right, so I'm sure we heard about exponents, exponent for plural. If we heard about indices and powers, index and power being the singular form, these are all the same things. Okay, so express each of the following products in index form. So what we want to have the power. I'm sure you're more familiar with that. So we're going to keep the base 3, 1, 2, 3, 4. Okay, so the 4 simply indicate that we have 3 repeatedly multiplying by itself. Again, how many times do we have A multiplying by itself here? 1, 2, 3, 4, 5. We have Q here multiplying by itself a number of times as well. So you can pause the video and complete this really at any point. 1, 2, 3, 4, 5, 6. And so we have Q to the 6. Let's check it again. 1, 2, 3, 4, 5, 6. That's Q to the 6. Okay. In your textbook, there's an extra Q. So notice it's only 1, 2, 3, 4, 5, 6. In textbook, there's an extra 1, so you have Q to the 7th. All right, here we have R times R times R, going right up to the mth term. Now notice that how many terms we have here? 1, 2, 3, 4. So right up to the 4th term, right up to the 5th, right up to the 6th. In your textbook, you should have up to the 7th. And this R is going right up, the dots mean, and so on to the mth term. So we write R to the mth power. And X, in this case, going right on to the zth power. So write it X to the Z. If you have these, then that's really good. Let's move on to multiplication of powers and quantities raised to a certain power. So we have 5 to the second times 5 to the third. Well, first of all, we know what 5 to the second means, 5 times 5. And 5 to the third means 5 times 5 times 5. So in fact, what we have there is 5 times 5 times 5 times 5 times 5. We're repeatedly multiplying 5 by itself 1, 2, 3, 4, 5 times. So in index form, this is 5 to the 5th power. Now, if you look at this that was given here, could we have done this a shorter way? What could we have done with the powers to derive 5? Well, if we kept the base 5 and we added the powers 2 plus 3, by intuition we realize we do indeed get 5. Correct? Alright, so let's try another example and see if it works as well, that we don't have to go through this long procedure or process. We have a to the 4th, which is a times a times a times a to the 5th, which is a times a times a times a times a. So we have a. How many times do we have a in all? We repeated multiplying a by itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Is there a shorter way? What could we have done with 4 and 5 to derive 9, referring to the powers? Well, 4 and 5, if we add them, we do indeed get 9. And this is exactly what we did in the last example. Okay, when we take this off again, this should be a 5. So 5 plus 4, 4 plus 5 gives us 9. So in general then, if we have a quantity referred to as A in this case, times another quantity, same quantity, raised to a power n, we keep the base and add the powers. Now this only works when we have the same quantity being raised to a certain power. They have the same base that we keep. Okay, so bear that in mind. So what note you want to take note of, what you want to take note of is this. You can write down if you desire. When we multiply quantities with the same base, we keep the base and add their indices. Okay, by multiplying quantities with the same base, in this case A, we keep the base, I'm keeping it here, and add the powers, or indices, m plus n. Now, m plus n cannot be simplified in this case because they're unlike terms. But when we deal with numbers, we can simplify them. Now, this is example 51. Let's say you could pause the video and go through this. You could pause the video and go through this. All right, assume that you have done that. Let's work it out together. So we keep the base, which is 2, add in the powers, 4 plus 5. That gives us 2 to the 9th power. They want the index form. So we're not writing out the value, we're just writing it in index form. In this case, we keep the base as well, add the powers, 3 plus 5 give us 8. In this case, notice that we don't have the same base here, so we're gonna have to do some grouping. So we can reorder them. The way you multiply, the order doesn't matter. So we're gonna reorder these and then multiply them. So we're gonna have here is x to the third times x to the second times y to the second times y to the fourth. And what we're going to have next, let's simplify this further. This will give us, let's make sure we can put this over there. And so we're going to have here x to the fifth, 3 plus 2 is 5, and y to the 2 plus 4 is 6. Okay, so that's our solution there. All right, so I'm lacking space, so let me just take this off. Hopefully you will have this already. So I can write my answer here, which is x to the fifth, y to the sixth. Okay. Memento. And this will be r by itself there. Let me check the textbook quickly. That's r to the third power. Okay, so let's simplify this together. Now again, if we want to apply the rule that we learned earlier, we want to ensure that we are multiplying quantities with the same base. So this calls for us to reorganize them according to the bases. So we're going to write p to the second with p to the fourth. They're not like terms, but they have the same base. We're organizing them to apply the rule. Q to the third times q to the fourth. We're left with now r times r to the third. So we keep the base, which is p. Add in the powers, we get p to the sixth. Keep the base, which is q. Add in the powers, we get 7. Keep the base, which is r. Add in the powers. Now indicate, let's look at this, that r is the same thing as r to the first. If we're not seeing the power, it's actually to the first power. So we're going to add them. 1 plus 3 give us 4. And that's our solution. P to the 6, Q to the 7, R to the third. And ensure that you know that we're actually multiplying these. P to the 6 times Q to the 7 times R to the fourth, but we usually don't write the multiplication. Okay, let's go down to division of indices with the same base. Now if we have 2 to the 5th divided by 2 to the third, it can actually be written vertically. The first one is the numerator, and the second one is denominator. Okay, I'm referring to this as the numerator power and denominator power, the bottom number. 2 to the 5th is 2 times 2 times 2 times 2 times 2, and 2 to the third is 2 times 2 times 2. Now what I've done here is to cancel out the 2's, 22 goes 1, 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 22 goes 1. So I'm left back with 2 times 2, and which can be written as 2 to the second power, repeatedly multiplying 2 by itself twice. Notice that 3 of the 2's at the bottom cancels out, well, 3 of the 2's at the bottom cancel out the 3 of the 5 2's at the top. 3 cancel out 3 of them, and we are left with 2 of them, 2 to the second power. The question is, what could we have done with the 5 and 3 to get to the second power? Okay, so if I take off this so we can do a little thinking there, what would we have done with the 5 and the 3 in order to derive the 2, referring to the powers? 5 and 3 to derive 2. Well, if we subtract the denominator power from the numerator power, so we're going to have 5 minus 3, we'll indeed get 2. Okay, and let's try that now with us with the variable being 2. Oh, sorry, that the base being a base, the base being a variable. So what we do here is write the numerator on top, the denominator below, the first numerator, second one denominator. A to the fourth mean a times a times a times a. A to the third mean a times a times a. All three will be cancelled off with 3 at the top, leaving 1. So what we have here is a to the first power. The question is, what could we have done with 4 and 3 to get 1? Well, if you said subtract, then you're correct. 4 minus 3, 4 minus 3, 4 minus 3 will give us 1. So it actually works. So we can do it the long way or the short way. So the general rule is if we are dividing two quantities with the same base, we can actually keep the base and take the denominator power from the numerator power. The numerator power goes first minus the denominator power. Okay, so let's look at example 52 where we can practice some practice. Example 52, we can do some practice. We have here 5 to the 9th divided by 5 to the 8th. You can pause the video, go to the textbook itself if you want to, work them out, and then check the solution. Let's go through these. Dividing quantities with the same base, in this case 5, we subtract the power, and so I'm going to have 5 to the 1 power, same thing as 5. When it's to the 1 power, we don't need to show it. Here, we keep the base, which is a, and subtracting the powers, 5 from 12 give us 7. Don't think I need to have to write that, right? Do I? Now in this case, we're gonna, well, if you notice, we're dividing these two, so we're gonna subtract the powers. Now this is our numerator quantity, denominator quantity. Okay, I think it's easier to actually see it this way. If I have x to the fourth, y to the third on top, and then x, y to the second below. Okay, now x down here has a 1 power. So if I subtract 1 from 4, leaves 3. So that gives me x to the third so remember to take the denominator power from the numerator power, gives us x to the third. Taking the 2 from the 3, this gives me y to the first, which is the same thing as x to the third y. I do not need to put the 1 if it's 1. Okay, all right, was that understandable? Let's look at the next one then, the last one, D. Okay, so I've pre-written this. This is going to be the numerator divided by the denominator. Okay, so I write it vertically. So the same thing we're going to do, we're going to keep the base p, subtracting the powers, 5 minus 3. You don't need to write it out like this if you can subtract it in your header. Okay, but let's do it just so you can see what's happening. 4 minus, now this r has a power of 1. So we write 4 minus 1, and then our answer will be p squared q to the first power, which you don't need to write, and r to the third power. Did you get that? Okay, so if you have that, then we're ready to move on to the last one, power to power. Okay, right, so now let's look at this one. I think I need to take off these so we can actually do some figuring on our own. Okay, so what we have here is 2 to the third. Hopefully you can see it, and this can be found on page 277. You can actually look at it if you choose to. We have 2 to the third. Let's take this out so we can write it better. We have 2 to the third squared. So I'm squaring the quantity 2 to the third. That means I have 2 to the third twice. 1 twice. All right, once twice. 2 to the third times 2 to the third. 2 to the third is 2 times 2 times 2. 2 to the third is 2 times 2 times 2. If you write it out long way, just remove the brackets. And we have 2 repeated and multiplying by itself once, twice, 3 times, 4 times, 5 times, 6 times. Right up to the 6th term. So 2 to the 6. So what we could have done with 3 and 2 to get 6, looking at the powers, what could we have done with 3 and 2 to get 6? If you said multiplication, you're correct. So when we raise a power to a power, it seems as if multiplying the powers would just be a simple solution. Let's try this one and see if it works. P to the third raised to the fourth power. Raising to the fourth power, that means we have p to the third repeated and multiplied by itself once, twice, 3 times, 4 times. If that's the case, then we're going to have p times p times p, p times p times p, p times p times p, p times p times p. How many times we have p multiplying by itself in all? 3, 4, 3, 6, 9, 12. 12 times. And so we have p to the 12th power. What could we do this a short way? What could we have done with the powers to get 12? If we said multiplication again, you're correct. So multiplication seems to work when we're raising a quantity with a power to another power. So therefore, we can generalize this as saying when we have when we raise the power of a quantity to a power, we raise the power of a quantity. When we raise m, right, which is of the quantity or the base a, to a power n, we simply multiply the powers, m times n. Hopefully that was understandable. And m times n can be written as mn. Okay, so let's look at these and see if we can solve them. All right. We're raising 5 to the second power to another power 7. So we basically keep the base 7 and multiply the powers, 2 7s. If you said 5 to the 14th, you're correct. We want these answers in index form, so we're not going to multiply this out. Keep the base, which is x, multiply the powers, we get 3 fourths 12. Okay. I mean, if you can do it in your head, you don't need to write this out. Just simply put it down. In this one look a little tricky, but all we need to do is simply multiply the powers. 3 fourths 12 and 2 fours 8. Multiply the powers on each part of the term. Okay, let's now see if we can apply this rule right here as well. 5 has a power of 1 and 3 has a power of 1. M has a power of 2, N has a power of 3. So we're going to multiply. Now this bracket is around everything. So therefore multiply. We're distributing this power on all these powers by multiplication. So we're going to have 5 to the 1 power times 3. M to the second power times 3. 3 to the first power times 3. And n to the third power times 3, which is 5 to the third power m to the sixth power divided by 3 to the third power and n to the ninth power. Okay, so this is 5 times 5 times 5, which is going to be 125. M to the 6. Okay, so we should know that 5 times 5 times 5 will give us 25 times 5. Here I record part by part, so we have 25 here times 5 is 125. This is something you should know by heart. Okay, if we have 5.25 cents, it's $1.25. So that's a good thing to look at. And 3 times 3 times 3. So we have 3 times 3 times 3. 3 threes is 9. Multiply by 3, and 9 threes is 27. Again, you should know that as well. Those are popular. 5 to the third power and 3 to the third power. Those are very popular, so you should know those. Okay, so our solution is 125 m to the 6 divided by 27 n to the 9th power. If you have those as your answer, then you did a great job. If not, then you can make your corrections, and I still think that you did well if you're paying attention. So for homework, you can look at these. For homework, have a look at these. Okay? We have here 6 to the third times 6 to the 7th, 4 to the 5th times 4 to the 2nd, x to the 7th times x to the 9th, m to the 4th times m to the 3rd, m to the 4th raised to the 3rd, a to the 2nd raised to the 3rd, 5 to the 3rd times 5 to the 9th, x to the 6th times x to the 12th times x to the 3rd, x to the 3rd raised to the 4th power times x to the 5th, m to the 4th times m to the 5th raised to the 2nd power times m. Okay, so you can complete this assignment and turn it in to me. Thank you for watching, and I do hope you enjoy this. I am Mr. Lennon, your tutor.